Hi, today we are actually looking at the unit circle finally. We've been working and learning a lot of bits and pieces to help us get to this point, and today we're putting it all together and we're seeing the big picture. So first thing that I want you to do before we start this activity is at the bottom of the sheet right here, I want you to cut off those triangles and cut them out. So you're literally going to cut them off your sheet, and then you are going to cut them out. And we're going to label the sides of those triangles with what we've been working with, our special right triangles. So when it's 45 degrees, we're going to do root 2 over 2, root 2 over 2. On the 30, 60, 90, there's 2 of those because that will make the activity a little easier. So remember that the side opposite the 30 degrees will be 1/2, and the side opposite the 60 degrees will be root 3 over 2. So pause your video, go cut out your triangles, go label your triangles, and I'll see you right back here in just a moment. Okay, great. Set those aside for just a moment, and let's talk about what we've been doing over the last few weeks. These are the things that we know because we've studied already. The first thing is we talked about the coordinates and how when we have our x-y coordinate in the rectangular system, that's the same thing as cosine sine theta in the trig stuff that we're doing. And so that would make x equal cosine theta and y equals sine theta. We talked about the radius of the circle, and we could use a distance formula to calculate the distance if we needed to, and that r couldn't be 0. And then on another day, we studied identities. And so these are some of the identities that we're going to use very heavily today. Tangent of theta is sine over theta cosine theta, and cotan is cosine sine. So those are the quotient identities. And then we're going to use these two particular reciprocal identities, the fact that secant of theta is 1 over cosine of theta, and cosecant of theta is 1 over sine theta. So important identities. We've worked with more than that, but that's what we're the main ones we'll use today. And then we spent some time reviewing our knowledge of special right triangles, and we learned or remembered, because I know you learned this actually in geometry, that you have a pattern relationship to the sides of x root 3, 2x. And that's the general pattern for any 30, 60, 90 triangle. And then specifically, when the hypotenuse was 2, then we had a side length of 1 and a side length of square root of 3. And we could lay out the triangle, always putting the 1 opposite the 30 and the root 3 opposite the 60. Then we had our second special triangle, which was 45, 45, 90, which has a side pattern of x root 2. And that's true for any 45-degree angle, which makes the sides 1 and 1 and the hypotenuse root 2. And then we reviewed our quadrant work, where we talked about the points in quadrant 1 that when you graph them are always plus plus, over here minus plus, up here minus minus, and in the fourth quadrant plus minus, because you would graph in the positive direction and then down. We have a saying, all students take calculus, that help us know in each of those quadrants what trig functions are positive. So the A means all functions, trig functions are positive in the first quadrant. In the second quadrant, it's just sine and its reciprocal cosecant. And then in the third quadrant for the T, it's tangent theta and cotan theta. And then in the fourth quadrant, it's C, which stands for cosine theta and secant theta. And those are the things that are positive in each quadrant. And then finally, last class period, we worked on learning how to find reference angles and how to use them. So these are all the things that we've been piecing together, all the little pieces. And today we're putting the puzzle together to give us the big picture of what we've been learning and how it all fits together. So now we're actually going to use the circle activity. So this is the unit circle activity that you're given in class, and you can print out if you're having to do this from home. And we're going to fill all of this information in based on things that we've been studying. So the first one that we're going to fill in is all of the information about the quadrants that we just talked about. And I'm going to give you a minute to do this, or you can, not a minute, but you can pause your video to do this and then jump back in with me. So this is quadrant 1, 2, 3, 4. The points here are plus, plus, minus, plus, minus, minus, plus, plus. And then we have the saying, all students take calculus, and what is positive in each quadrant based on those. So take a moment, pause the video if you need to, and make sure you have all this information in. As we add a new topic to our sheet, I'm going to do each topic independently on its own paper. You're going to keep layering them on top of this activity that you're starting right now until you have all this information filled out. And then on the last paper that I have to show you, I'll show you my sheet all filled out. So make sure you have all the quadrant information. All right, now that you have all of this filled in, the next thing we're going to do is work on filling in our 45-degree angles. So remember when we talked about where those are earlier, we would have this right here. And you have these triangles for a reason, because we are actually going to take that triangle, we are going to put a 45-degree angle at the origin, we're going to put the right angle right here on the horizontal axis, and that you can see lines up with this point right here. So this is my 45-degree angle. So in the center I'm going to put 45 degrees, but what is 45 degrees as a radian measure? Pi over 4, I hope you said. The length of this side was root 2 over 2. The length of this side was root 2 over 2. So when we fill in this coordinate right here, we're going to put root 2 over 2, root 2 over 2. And that will be pi over 4. And then we're going to flip that triangle over so that it is in the second quadrant, keeping the 45-degree angle here, the right angle on the horizontal axis. Let that point line up. So when we do that here, keep in mind we have directions that we're graphing. So we're actually going to graph in this direction root 2 over 2, which makes that the negative direction, and then up root 2 over 2. So this is going to be negative root 2 over 2, and this is going to be positive root 2 over 2. And then we're going to take our triangle and we're going to flip it down into the third quadrant. And we'll line up the sides. So now this time it is negative direction and negative direction. So negative root 2 over 2, negative root 2 over 2, and those are the coordinates you're going to put there. And that should make sense because we talked earlier about points in this quadrant should both plotting directions should be negative, and we just found this to be negative root 2 and this to be negative root 2. And then finally, to fill in the last quadrant, I'm going to reflect that over, put it in here, and then I'm going to measure positive direction root 2 over 2, negative direction root 2 over 2. So this coordinate is positive root 2 over 2, negative root 2 over 2. And that's how you're going to lay in the 45-degree angles. So press pause, take a minute, make sure you have those filled in. So hopefully you have all the quadrants filled in. So you can see here's where my triangle was. I wrote and labeled pi over 4 up here next to the dot. I have 45 degrees next to the center at the origin. And then these were the coordinates that I just found. So if you think about what's happening right here, that should tell you a lot about the coordinate signs on your coordinate points. So this is plus plus. This is also plus plus. Over here it should be minus plus. Guess what over here is? Minus plus. It should be minus minus in quadrant 3, and it is minus minus. And it should be positive minus in quadrant 4, and it is positive minus. So you can see how those fit in. All right, so the next one we're going to do is the 30-degree angle. So I'm going to get my 30-degree triangle out that goes right here and lines up like that. So down here, we're going to have an angle of 30. Up here, we're going to have an angle of pi over 6. Because remember, if it's 30 degrees, then it's pi over 6. And so when we look at the measurements, you can see that the length along the horizontal axis is root 3 over 2. So I'm going to put that measurement right there. And the length up is 1/2. So I'm going to put that measurement right there. And then we're going to do just what we did with the other one. We're going to flip this triangle over and put it in this quadrant. So then it would be, and so that's where sometimes having them labeled on the back can be helpful. So over here, then we're going to have negative root 3 over 2 and positive 1/2. And then we're going to flip it into the third quadrant, just like we did the 45. Just going to line up right there. So then this quadrant, it's going to be negative negative. So it's negative root 3 over 2, negative root 3 over 2, and that's what you'll put here in those quadrants. And then we're going to take it and flip it into the fourth quadrant. And so then when we're in the fourth quadrant, we're going to have positive root 3 over 2, and then down negative 1/2. So that's what's going to go in this quadrant. So pause your video right now and make sure that you have all of those things labeled. And then before we pause, let's go ahead and count that off. So we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So that was all the pi over 4s a moment ago. And then we're going to count just the pi over 6s. So I would have pi over 6 here. And then I'm going to work my way around to those triangle points that we just had. So go ahead and fill those in, and then once you come back, we will move on to the next angle. Okay, so hopefully you have those on your circle. Now remember, right now you have all of the pi over 4s filled out and all of the pi over 6s filled out. And as we keep adding, you're going to keep adding to this paper. All right, so if I'm counting this off, this would be 1 pi over 6, and remember we're counting every 30 degrees. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. And this 5 pi over 6 is the first one I've counted off that doesn't simplify. Then I have 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, and finally 11 pi over 6, because when I get right back here to 12 pi over 6, that would be 2 pi. Okay, so the next one that we're going to do is 60 degrees. So you're going to take your 60-degree triangle out, put the 60 degrees at the origin, put the right axis on the horizontal axis, and then that moves right up here. Okay? So when you're doing this one, we know that the length here would be 1/2, and the length up would be positive root 3 over 2. So you're going to have 1/2 root 3 over 2. Can you see that that's very similar to pi over 6? Why do you think that is? Well, they're complementary angles in the same triangle. So if you notice that what we just said, 1/2 root 3 over 2, is just these two places trading. But then think about what that triangle looked like. When I had the 30 down here, we had the 60, but now that the 60's down here, we're up there with the 30. So just a couple of things to think about. So now we're going to flip it over into the next quadrant, and then I will have 1/2, but remember in the negative direction, so negative 1/2 positive root 3 over 2, and that's what you put right here. And then I'm going to rotate that down into the third quadrant. So I would have 1/2 negative 1/2 negative root 3 over 2, and that's what's going to fill in the coordinate right there. And then I am going to reflect that into my last quadrant. And then it would be positive 1/2 down negative root 3 over 2. So this would be your negative side, and that's how you're going to get those coordinate points. So remember that we would be labeling them right here, and it's pi over 3 because it's 60 degrees. So then you're going to fill in your pi measurements around your circle. So pause your video, go fill in those 60-degree or pi over 3 angles, and we'll be right back. Okay, so hopefully you have those coordinates in. Now let's count off the radians. So this is 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3. So we have our pi over 3's taken care of for each of those angles. So now let's fill in the quadrantal angles and other angles. For instance, we've only been looking at cosine and sine, but there are secant, cosecant, cotan, and tan. So the next phase that we're going to do is a look at some of those values and get our quadrantal angles. So before we do the rest of them, I want to refresh your memory about some of the identities that we're going to use right here. Because the circle is all in cosine and sine, I'm using the identities here that all deal with cosine and sine. So can you see on this side how everything is like, so sine or cosine, you don't see secant, cosecant, cotan, or anything like that. So when I'm calculating any of these values, I'm going to use the appropriate trig function. So what I want you to do now is up here in the corner of your paper, I want you to find cosecant, secant, tan, and cotan of pi over 3, pi over 4, and pi over 6. So we're going to complete these values. We're only going to do it in the first quadrant because I want you to have the numbers, but then we know from what we know about these signs that we can move these around and translate them into different quadrants using the same number, but just adjusting the sign. So take a minute and find those 4 trig functions for each of the 3 main ones here. So you're filling this in. Cosecant of pi over 3 equals what? Tangent of pi over 3 equals what? All the way down through here. All right, so hopefully when you were calculating these just now, you got these values. We have for cosecant of pi over 3, it's 2 root 3 over 3. For tangent of pi over 3, it's root 3. For secant of pi over 3, it's 2. For cotan of pi over 3, it's root 3 over 3. And then when I move to pi over 4, then I say cosecant of pi over 4 is root 2, secant of pi over 4 is root 2, tangent of pi over 4 is 1, and cotan of pi over 4 is also 1. So you can see some patterns that develop there. And then the last one we're doing for pi over 6, so it's cosecant of pi over 6 is 2, secant of pi over 6 is negative 2 root 3 over 3, tangent of pi over 6 is root 3 over 2, and cotan of pi over 6 is root 2. So now we're going to do the same thing, but we're going to do the quadrantal angles. So we're going to find cosecant and tangent and secant and cotan of all the quadrantal angles. So right here at pi over 2, right here at pi, down here at 3 pi over 2, and over here at 2 pi. So pause your video, go fill those in. Remember to use those identities that we talked about from the last sheet, secant, cosecant, tangent, and cotangent. All right, so hopefully you found some interesting things. For instance, like on pi over 2, tangent of pi over 2 is undefined because you are trying to divide by 0, and you can't do that. So I found tangent of pi over 2 is undefined, as well as secant is undefined. Cosecant of pi over 2 is 1, and cotan of pi over 2 equals 0. But look what happens when we move to this quadrantal angle. Now it's cosecant of pi that's undefined and cotangent of pi that's undefined. So that leaves tan of pi to be 0 and secant of pi over 2, or excuse me, secant of pi to be negative 1. And then I went over here to 3 pi over 2, and tangent and secant are undefined. Cosecant is negative 1, and cotan is 0. And notice it's of the angle 3 pi over 2. And finally, around to here, so we have cosecant of 2 pi, which is undefined, cotan of 2 pi, which is undefined, tan of 2 pi, which is 0, and secant of 2 pi equals 1. So once we have all of that, then we also have our quadrantal angles. So remember, we go 0, pi over 2 pi, 3 pi over 2, 2 pi. The coordinate to move out here is 1, 0. Up here is 0, 1. Over here is negative 1, 0. And down here is 0, negative 1. Great. Now that you have all that down, you should have a unit circle that looks very much like mine. So we have our quadrantal angles, we have our plotting points, we have our coordinates, and all of this put together makes up the unit circle. So hopefully yours is as filled out as mine. If after having completed this activity, you want a blank one, that will be on Canvas, and you can create another one if you want to do something like color coding or organizing now that you know what all's on it. You can see the sketches of each triangle that we put over here, the values up here, and all the way around. So a few things that are worthy of noting is if you look at this, it's 2 pi over 3, 3 pi over 4, 5 pi over 6. All of the radian measurements in this quadrant over here, the numerator is always 1 less than the denominator times pi. And remember, standard form will put the pi up in the numerator, not behind. If you look at the pattern of these over here, the numerator is always 1 more than the denominator times pi. So here it was 1 less, here it's 1 more. And then finally the third quadrant, you know, those are just ones I think I get to know. But the pattern that you should do kind of see is that the numerator is always 1 less than twice the denominator times pi. So what I need you to do is kind of make sure you're getting this down. Everything in this first quadrant should be memorized. Everything should be memorized, and you should know it. Forwards, backwards, sideways, upside down, and standing on your head. It just needs to be really, really second nature. Okay, so because you know you can move everything and push everything around into different quadrants using, all students take calculus, using reference angles and those kind of things. As long as you have all of this memorized and you know your quadrantal angle stuff, you can generate all of this information pretty fast. But I'll be honest, a lot of this will become part of your working memory. You're going to use these common ones so much that you're just going to get to the point where you know them. And finally, I have one last thing to show you. And this is just because I wanted you to have some visual awareness of what's going on. So I made a grid and I put a circle on it. Well, the first thing I did is make a big triangle out here to represent a 45-degree triangle. And you can see I have x, x root 2, and x, because those are the patterns from our special right triangle that apply to every 45-degree triangle. And then if you imagine putting this circle on here to where if I go down my general triangle to this point, that's 1 unit long. And when that's 1 unit long, then if I take 1 set equal to x root 2 and I solve for x, I find that the length of the side is root 2 over 2. So the length of this side is root 2 over 2 and the length of this side is root 2 over 2. So what you have is a special case of the overall pattern of a 45-degree triangle. So then I drew a 30, 60, 90 over here, and I just kind of reflected it and did it this way just so that they weren't on top of each other so you could see. So you can see the general pattern of the legs and the hypotenuse are 2x, x, and negative x root 3 because I'm actually going in the negative direction. And then the point right here that intersects the circle, creating this triangle right in here, ends up giving me a height of 1/2 and a length of negative root 3 over 2. So that's what that is. So what I have here from here to here is 150 degrees. From here to here is the reference angle of 30 degrees. And so everything I calculate with the 30 degrees has the same equivalent value as that I'm calculating with 150 degrees. And it does that because of this relationship and how these two things are tied together. So I wanted you to see that those triangles are similar, that this one is the big general overviewing triangle that works for all 45, and then when we go to our special right triangles, that's a special case of that triangle, and that's a special case when the hypotenuse of that triangle is 1. Okay, so you have some note questions to work through, and I did put the examples in a separate video, so if you're needing help with those particular questions, then you'll want to look at that lesson where we talk through those questions on the note sheet. Thanks so much.